Good morning, grade 9s. We're looking at how to prove triangles similar because triangles are special shapes. So from yesterday, we saw that if it's any shape, other than triangles that is, then it is required for similarity that the corresponding angles are equal and the corresponding sides are proportional. But for triangles, if we only prove the one thing, either A, that the corresponding angles are equal, or B, that the corresponding sides are proportional, the other one is automatically true. Okay, so if we prove the corresponding angles are equal, then automatically we know the corresponding sides are proportional. Okay, and then if either then the corresponding sides are proportional, it's proven, then automatically the corresponding angles will be equal. So we need to prove only one condition, then automatically the other is true. So example 1, let's have a look, see here. So we have to find specific details, and you can see there's very little given other than we have to prove that the two triangles are similar. We know that we have to prove it's similar because of that symbol. And they say if AB is parallel to DE. So you can copy this diagram into your book and then write the example down with me. So pause, copy, write with me. And I think that's the best way to learn this. Now, the given information, I always fill in onto the diagram. It just helps me see the details more clear. And I have been given AB is parallel to DE. So if I have this, then we see ABC is inscribed into, ABC is the big, let me try that, big triangle, and DEC is the little triangle inscribed into the big triangle ABC. And I notice that since I have parallel lines AB and DE, that it forms an F over here. Okay, so that angle should be the same size as that angle, and they're in the different triangles. So we can prove that we have an equal angle from the two different triangles, and that is our goal, to prove, remember, angles, or to prove sides proportional. Now, it doesn't help I prove sides proportional here because I don't have any measurements of the sides to work with. So obviously I have to prove the angles, and automatically I will know that the sides are proportional. So if I have an F this way and it's equal, then automatically I should know the other way should work as well. That angle should be equal to that angle. I'm going to draw all of this in now. And then the other thing is that C is called a common angle. And as you'll see on the next page, there's another way to solve the third angle always. You don't have to necessarily use a different manner. Okay, but let's just carry on solving this. So we have seen then, I'm going to highlight these things for you, that is an F formed by the parallel lines this way. So we know this angle and this angle is the same size. There's an F formed the other way. And remember, we have to prove three things normally. Those two angles are equal. And then this angle over here belongs to both of my triangles. It's part of DEC and it's part of ABC. So it should be the same size since it's the same angle basically. And now I start solving. So let's see. You always start by stating in which triangles you work, because sometimes there's just more than two triangles. You're going to see in some of our worksheet questions. So in triangle ABC, now this has to be in corresponding order, which I'll talk about more just now, and triangle DEC. So let's see the way that they're positioned. I see A is going to be equal to D. So I know I have to write them in the same order. A and D, B and E, so they should be next, and C and C are equal, so they should be last. So DEC would work. Okay, so in these two triangles we have the following. Firstly, number 1, and you can number it if you like, but we don't normally do that. But the first thing I'm proving is that, so we have three angles to prove. Angle A is equal to angle D2, like you can see in the diagram. because, so regardless of the actual size, we just have to prove they're equal, remember? So that A is equal to D2 because they're corresponding angles, so corresponding angles, and that is between the parallel lines AB and DE, okay, as given in the information above. And now we move on to the next thing proven. That is that angle B over here is equal to angle E2. So angle B, once again, or I'll show you something just now. B is equal to E2. And they're also corresponding angles. And that also between the parallel lines AB and DE. Remember that you have to write your parallel lines if you're using the fun angles. And then the last thing is this angle C that they have in common here, the same angle basically. And so we write angle C is equal to angle C because it's in each of them. So that reason is just common angle. Okay. And now we have proven 3 angles equal, although the third one is equal by default actually, which I'll explain just now. So therefore, triangle ABC is similar to triangle DEC. And you can actually find your order in which you write it, the correct corresponding order you can find over here. ABC, DEC. So angle equal to angle should be in the same order. Okay. And then you'll also see something here. I have firstly mentioned in my statement over here at the start ABC. So every time I wrote the angle from ABC first, and then the second mentioned triangle's angle that is equal to second. Okay, so ABC on this side, DEC on that side. That's something that's very important as well. Now we have to write a reason as to why we say that they are similar. And that would be either the corresponding angles are equal or the corresponding sides are in proportion. Now we have a different way of writing that the corresponding angles are equal because that's what we've proven here. That's the part we used. So we then just write angle, angle, angle in that manner, or you can write equiangular as in the same angles, triangles, equiangular triangles. Okay, then the hints, and this is where I'm going to talk about something that they're using over here, the angles in the triangle. So usually this is how it's going to work. So use colored highlighters to trace around the 2 triangles that you're trying to prove. Read the wording of the question and add info to your diagram like I did. And then set up your proof to look like this. The statement in triangle this and that in corresponding order. Angle this is equal to angle that. Angle this is equal to angle that. And angle this is equal to that. And then, so for the first 2, you have to find the information from the diagram. But for the third one, sometimes you can use the fact that if the other 2 angles are equal, automatically by default, the third set of angles should be equal because the sum of the interior angles of any triangle should add up to 180. So since the sum of the interior angles is the same, if you subtract those same angle sizes from 180 in each of the triangles, you end up with the same remaining value for each of those angles remaining. Okay, so I hope that clarifies something. Then sometimes, so thereafter, after I've proven the 3 angles equal, thereafter I say therefore triangle this is similar to triangle that, and equiangular triangles, like I said, or we can say angle, angle, angle. And then do this last step only if asked to work with the sides that are now in proportion, and we can have a look at that example just now. Then you say this proportion is equal to this proportion for the sides is equal to this proportion. Okay, I'm going to show you how to write that just now. And then you say that they are in proportion, because this is basically what it says, because we're working with the similar triangles proven above. So now calculating lengths of sides of triangles that you use similarity with. So now in the previous one we proved, and sometimes you're going to prove triangle similar and then move along to finding the values of missing sides. But now in this example, it's been given to us that the triangles are similar. Now they're saying determine the values of y and b, and now the if is not parallel lines like in the previous one, but that the two triangles given here are similar. And now in this case, it's very important to locate the corresponding side lengths, because we're going to work with our side lengths. But as to that, our angles, which are equal, helps to make this easier. So we can see that this angle is equal to that angle, and this angle is equal to that angle. And by default, like I said in the previous one, the third set of angles should be equal, Z and B. Okay, so therefore we can see the corresponding angles are XY corresponds to AC, because both of them have got the open dot and the solid dot on the end points at each of the vertices of the triangle. And then I know that XZ is the corresponding side to AB, because both of them have the angles of the open circle and nothing on the end points of that line. And then I know that YZ corresponds to BC, because both of them have the solid dot and the open angle at their end points. Okay, so that would be my first point of business for this. Locate the corresponding sides, because your first part of your statement is, so let's see, in triangle ABC and triangle XZY, and you'll see that's the corresponding order. Okay, so we have that we know that they're similar, so we know that the corresponding sides are in proportion. And how do we write this? We literally say, so corresponding side XZ over corresponding side AB. So those correspond. That proportion that it forms, the fraction, is equal to XY divided by AC. And that in turn, that proportion is the same still and is equal to that of ZY to BC. Okay, so we have to write a reason for this. This is our formal statement, and this is the only reason you write, and that is that they are similar triangles that we're working with. Okay, or you can write triangle ABC is similar to triangle XZY. That would work as well. And now we're just going to work with the details. So I'm first going to say, therefore I know that XZ is, let's fill in Y. I'm going to use a different color pen for the variables. So Y divided by AB, which is given as 80, whatever units is being used. That should be in proportion with, and now we look for a set of angles which have both measurements given, which are corresponding, and that would be ZY, if you look carefully, ZY and BC. Okay, so now be careful. So now ZY is in the top. Okay, so we have to write it in the same order, ZY being 30 and BC is 60. Okay, so if you look at this further, this can be reduced to a half. So Y divided by 80 is equal to a half. And then you can solve it from that. So you can just times by 2. But the other way we use is to multiply across, and that solves y easily as well. And as I see over here, I'm going to need more space. So we just go like this. I'm going to use a different colored pen. This y times 60 should be the same as 80 times 30. And it's as good as just multiplying by the denominator and then dividing. It's the same process. So that gives you 60y. If you say y times 60 is equal to, and 80 times 30 is 2,400. Okay, and then we divide by 60 on each side to isolate y completely, and that gives you the 40 measurement. Okay, and we have said that it's half, so therefore it does make sense that it should be 40 over 80. I'm just going to do the final variable that we have to solve over here, and that was, therefore we also know that the only thing we haven't solved here was the xy over AC, so we're going to work with that next. So xy is given as 50, so that I'm going to write over here 50 divided by the corresponding side b. So this is my variable that I have to solve. Okay, is equal to the given proportion once again is for z, y, and bc, 30 divided by 60. And then we follow the same procedure of multiplying b with 30, denominator with numerator, and numerator with the denominator that way. And this gives you b times 30 is 30b, and 50 times 60 is 3,000. And then you divide by 30 on each side, and finally b's value is 100 units. And then we've solved for both y and b, the variables on the sides in the diagrams. Okay, now the work that you can look at is Spot on Mathematics Grade 9, Activity 3.4, Question 2, 5, and 6, and Worksheet Exercise. And there you see is exercise